Check one. Check one. Check one. Right. Good evening, everybody. Back again with our MCQ night session. Now, by now, we have finished off 2023 O-level paper, 2022 O-level paper, 2021 O-level paper. Three papers are done. We will have to proceed with 2020 O-level paper. New paper. The new paper. Ah, before we start, I'll open the groups. Tell me, is all the DOs perfect? All working good? Check from YouTube side as well. Perfect. Good. No? Right. So today, day one of 2020 O-level paper. 2020 O-level paper, we'll be doing question 1 to question 10. First set of questions. First set of question 2020 question 1 to question 10. Right? Before I start, small question. Yesterday I met you, today I'm meeting you, 24 hours gone. Are you satisfied with the work that you did for last 24 hours? That means today. Are you satisfied with your workload? Honestly, reply me. Are you satisfied with whatever you did? Hmm? Yes. Perfect. Perfect. Those who are still feeling no, it's not satisfactory level. I can do something more. This is not my maximum output for a given day. Whatever gone is gone. Today gone is gone. You can't reverse whatever the time. But tomorrow, make it the best day. Whatever gone, don't think of that. Don't think of whatever that is gone. It's gone. Think of what to do ahead. Next day, what to do. How to make tomorrow the perfect day. How to give your highest potential for tomorrow. Work with that kind of a aim. Okay? Right. I'll start the paper. While doing the paper, I'll talk to you all. First 10 MCQ. Now we all know the first 10 MCQ guaranteed there will be a what you call physical quantity question where they'll ask about unit or something. Some basic questions are there. Those kinds of questions. Section that I want to deeply discuss is section that I want to deeply discuss is question 8. A deeply discussable section is question 8. Displacement time graph. Displacement time graph. That is where you have to I have to discuss a bit long. Other questions are mostly direct. This one even they have given the diagram. Man. Such a inheritance question, like you can't expect in O-level paper. Even in our model papers, we don't give the diagram. Right? In O-level paper, final paper, they have given the diagram and asked what is the combination. Neither what they asking. Thalassaemic patients. So that no reason for you all to get scared. Things are things that you know. Right? Only thing is from your end, put the maximum work. That's it. Hurry. First, I'll discuss the 8th question and finish off. Then we will go in the normal order. 8th question. Displacement time graph. Onnapute, from your end, take your review book. Take your review book. Come to the table with your review book. And send me ready from your end. This has become like hide and seek. Every day you all know that I will ask ready. All at ready කියලා type කරලා යවනවා. Ready. Har. 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 Perfect. 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 Right. Displacement time graph. Onnapute, with today displacement time graph, everything should go into your mind. Hereafter, no regrets about displacement time graph. Right. Eyes on the screen, ears on the speaker. Listen very carefully. Displacement time graph comes under the section motion in straight line. Displacement time graph. What you do in displacement time graph? Lamai, in a graph, we have a y-axis, that's the vertical axis. X-axis, that's the horizontal axis. Displacement time graph, your y-axis is displacement axis. Displacement axis. Displacement is measured in meters, SI unit. X-axis is going to be time axis. Time is measured in seconds, SI unit. So we try to represent the variation of displacement together with the time. That is what we represent in a displacement time graph. Variation of displacement, that's the y-axis. With time, that's the x-axis. Remember, there are only few basic types of variations. There are only few basic types of variation. Now look at the board very carefully. Look at the board very carefully. Displacement time graph. I'll draw it bigger and explain first. Displacement time. I'll draw a general diagram. In a displacement time graph, this is a graph. In a displacement time graph, what does the gradient of the graph gives us? In a displacement time graph, what does the gradient of the graph gives us? Listen very carefully. What does the gradient gives us? See, what is gradient means mathematically will proceed. Gradient is difference in the y-axis divided by difference in the x-axis. Difference in y-axis divided by difference in x-axis. This is your y-axis. This is your y-axis. If I take difference in y-axis, that is the displacement. A change in displacement. Difference in y-axis is a change in displacement. Difference in y-axis is change in displacement. Divided by difference in x-axis. Difference in x-axis is my time. So difference in x-axis is time axis. You all tell me change in displacement divided by time. What does it give us? Displacement divided by time. What does it give us? This one don't get wrong. Even new grade 10s know that. Displacement divided by time. Third up acceleration loop. Velocity. Displacement divided by time is velocity. Displacement, there you go. Displacement divided by time. Displacement divided by time is velocity. That means I can tell gradient of displacement time graph gives us velocity. Gradient of displacement time graph gives us velocity. Gradient of displacement time graph gives us. Mathematically, what is gradient means? What do you mean by gradient in maths? The slope of the graph. Gradient means slope of the graph. See, if I give you two graphs, y-axis, x-axis, y-axis, x-axis. If I give you two graphs, one like that, graph number one like this, graph number two. Out of these two graphs, which graph has the greater gradient? Which graph has the highest gradient? Which graph's gradient is high? Out of 1 and 2? Perfect. Second one. Why? When the slope is high, gradient is high. When the slope is low, gradient is low. Slope gives us the gradient. Higher slope, higher gradient. Lower slope, lower gradient. This is maths. Higher slope, higher gradient. Lower slope, lower gradient. Okay. So gradient of displacement time graph gives us velocity. Now you all tell me, if I draw two graphs like this, displacement time, graph number one, graph number two. Which graph velocity is high? Which graph velocity is high? Second one. Why? Gradient of displacement time graph gives us velocity. Higher the slope, higher the gradient. Higher the slope, higher the gradient. Higher the gradient, higher the velocity. So second one, velocity high. First one, velocity low. Those are the basics. Right. Now going deeper. Displacement time graph. What does this graph tells us? Line upwards. What does this graph tells us? See, time is going. Displacement is increasing. Time is going. Displacement increasing. That means object is moving. If object is moving, it is having a velocity. Think, time is going, displacement increasing. Displacement increasing means object is having a velocity, it is having a velocity. What kind of a velocity? Can you see the line here is very smooth, very straight? If it is straight, it is having a uniform velocity. So this is uniform velocity graph. It is having a uniform velocity. Another word for uniform velocity is constant velocity. Now some students have a confusion. The uniform velocity graph is there. Is there something called non-uniform velocity graph? Yes. See, if I draw that same graph like this, graph is going up, but is it going up in a uniform manner? Check. Is it going up in a uniform manner? No. Objects, see, with time, displacement is increasing. Displacement is increasing. Is it increasing in a uniform manner? Oh, sometimes drop, sometimes increase, sometimes drop, sometimes again it's going, stopping, going, stopping, going. Here the vehicle is moving. So this is a non-uniform graph. This is a uniform graph. So here uniform graph, uniform velocity is there. That's your uniform velocity graph. That's a uniform velocity graph. That's your uniform velocity. We'll draw fully again. Now think, if you get a graph like this, displacement time, graph is going downwards. What does this means? Think, practically think. Oh, yeah, don't go guess and tell the answer. Practically think, what is the graph telling us? See, initially, very high velocity. Towards the end, velocity is very low. Initially high velocity, towards the end, velocity is low. Sorry, initially, velocity never, yeah. Initially, very high displacement, y-axis is displacement. Towards the end, displacement is very low. Starting with a very high displacement, slowly displacement is decreasing. Displacement is decreasing means lamai, object is moving forward or object is moving backwards. What do you think? Displacement is decreasing means object moving forward or object moving backwards? Guaranteed backwards. If it is moving, it is having a velocity. That velocity is uniform, straight line, it's not curved. Uniform velocity is there, but is the vehicle moving forward or backwards? Vehicle moving forward or backwards? Backwards. So this is uniform velocity backwards. Basically, you are going in the reverse gear. Here you are going with the forward gear, drive gear. Here you are going with the reverse gear. Same story. This is forward, this is backwards. This is uniform velocity, he is going forward or in positive direction. Displacement is increasing. This is same graph but backwards. Backwards, displacement is decreasing. He is reversing and going. Okay, so this graph is uniform velocity backwards. Uniform velocity, there you go, backwards. ඔන්න ළමයි එහෙනම් what is this? What does this graph tells us? Think. From the graph, think and grab the data that the graph is telling us. See, time is going. Is the displacement increasing? No. If the displacement increasing, graph should go up. Is the displacement decreasing? Time is going. Displacement not increasing. Displacement not decreasing. Object at rest. So that graph is object at rest. This is your object at rest graph. Object at rest. Only two more graphs. Only two more graphs are there. Displacement time. Displacement time. Graph like that. Curved line. Curved line. What does this graph tells us? Break it and think. See. Now listen. At the starting part, initially, the gradient of the graph is very flat. Can you see that? Graph is starting very flat. So initial part, if I zoom it very well and see, if I zoom this graph very well and see, can you see the bottom is flat? So starting flat. Look at the finishing part. Finishing almost in a vertical line. Starting part is flat. Finishing very high flat line, a very high vertical line. Starting very flat, finishing with a very high vertical line. My vertical line kya slope is very high. Slope is very high kya what can you tell about the velocity there? There the slope is very big. If the slope is very big, what can you tell about the velocity? High velocity. Ending high velocity. Starting flat line. What does flat line tells us? What does flat line tells us? What does flat line tell? Object at rest. So, starting with rest, finishing with a high velocity. Starting rest, finishing high velocity, rest to high velocity. You all tell me if you are driving a vehicle. Rest to high velocity. What do you need to press? What do you need to press? What is happening to the vehicle? Acceleration. This is acceleration. What kind of acceleration? Uniform acceleration. Why? This curved line is very smooth. I didn't draw it like this. I didn't draw like this. I drew like this. Very smooth. So what kind of acceleration? What kind of acceleration? Uniform acceleration. So remember when and where to use this word uniform. Uniform means a smooth graph. So this is a smooth graph, uniform acceleration. Even you can tell just acceleration doesn't matter. Uniform acceleration. How did I find it as uniform acceleration? Flat line to vertical line. Flat is rest. Vertical line is high velocity. Flat to vertical acceleration. Rest to high velocity acceleration. Object is accelerating. Now your turn. Now your turn. Displacement time graph. What do you think? What do you think? And break the graph, will you? Initially a vertical line. Slope is high. Towards the end, a flat line. Vertical line means high velocity. Flat line means rest. High velocity to rest. What is happening? High velocity to rest. What's happening? Deceleration. Smooth graph, what kind of deceleration? Smooth graph, what kind of deceleration? Perfect. Uniform deceleration. Uniform deceleration. There you go. Uniform deceleration. Tell me another name for deceleration. Another name for deceleration. Retardation. That's it, the graphs we have in displacement time. That's it, the graphs. See, nothing big, nothing big. See, displacement time graph, line up. Line up කියන්නේ velocity. A velocity is there, uniform velocity. Line down, uniform velocity backwards. Flat line, object at rest. Flat to vertical. Flat to vertical. Flat to vertical is acceleration. Vertical to flat. Vertical to flat is deceleration. Again repeat with me. Again repeat with me. Slanted line up, uniform velocity. Slanted line down, uniform velocity backwards. Flat line, object at rest. Flat to vertical, acceleration. Vertical to flat, deceleration. Again repeat with me. Now stop all the work. Repeat with me. Line up. Straight line up. Uniform velocity. This is forward motion. Uniform velocity. Line down. Uniform velocity backwards. Flat line. Object at rest. Flat to vertical. Flat to vertical. Acceleration. Uniform acceleration. Vertical to flat. Vertical to flat. Deceleration. One more time. One more time. With this displacement time graph is done. I think you can't make any mistakes. Again, one more time. One more time. Repeat loud. Straight line up. Uniform velocity. Straight line down. Uniform velocity backwards. Flat line. Object at rest. Flat to vertical. Flat to vertical. Flat to vertical. Acceleration. Vertical to flat. Vertical to flat. Vertical to flat. Deceleration. Is it? What is it? Things in the mind? Perfect. Perfect. Right. Ah, those are writing Dingala, right? Right now. We'll write. Okay. Now I will go to the question. Here is shown the displacement time graph of motion of an object during the time interval from 0 to t1, 0 to t1, and t1 to t2. The nature of the motion of the object respectively is 0 to t1. Look at the graph. 0 to t1. 0 to t1. Straight line up. Straight line up. What is the nature of motion? Straight line. Now everyone answer, right? Those who got that question wrong, everyone answer. Uniform velocity. Uniform velocity. Next, look at the remaining part. Can you see there is a curve? Can you see there is a curve? If I exaggerate and draw that, it's a vertical to flat curve. Agree with that? It's a vertical to flat curve. What is that? What is that? Retardation or deceleration. Now tell me what's the answer. Now tell me what's the answer. Answer number. Uniform velocity retardation. Now understood that part. Again, you can't get that section wrong. Understood? Play with the section. Perfect. Perfect. That's about that. Now we'll go in normal order. Question 1. Question 1. The fundamental structural and functional unit of life is, these questions don't get wrong. What's the fundamental structural and functional unit of life? Cell. Functional and structural unit of life is cell. Question 2. What is the pair of subatomic particles which attract each other? Tell me what are the 3 subatomic particles we have? Only 3 subatomic particles are there. What are the 3 subatomic particles we have? Electron, proton, neutron. Electron, proton, neutron. Electrons have what charge? Electrons have what charge? Negative charge. Protons have what charge? Positive charge. Neutrons are zero charge. Neutrons are zero charge. Now, for the subatomic particles to attract each other, for them to attract each other, they should have opposite charges. What two can attract each other? Proton and neutron. What's the answer? Answer number. Answer is answer number. Question 3. Unit of momentum is. Now this question, can you remember when we were doing another paper? we came across that question? Can you remember? We touched that question. Momentum. Momentum lamai equation is P equal mv. P is momentum. Momentum equals mass into velocity. Momentum equal mass into velocity. Mass is measured in kilograms. Velocity is measured in ms to the power minus 1. Once when you multiply, what's the unit of momentum? Kg ms to the power minus. What's the unit of momentum? Kg ms to the power minus. Then your answer is answer number 1. Answer is answer number 1. Okay. Question 4. Very repeated type of question. Now, once when you see this diagram itself, answer should come into your mind. Figure ABC below indicates 3 types of muscle tissue. Lamai, what is this? What is this? When you see itself, answer should come into your mind. That is smooth. Smooth muscle tissue. Now, these two. This is branch, this is unbranched. Branch 1 is cardiac. Branch 1 is cardiac. Then unbranched 1 is skeletal. Spindle shape. Branched is cardiac, unbranched skeletal. Smooth, skeletal, cardiac. ABC above respectively are. Smooth, skeletal, cardiac, answer number 3. Look at the questions coming in final low-level paper. Right? Smooth, skeletal, cardiac. Answer is answer 3. Question 5. Which of the following is the molecule with highest number of covalent bond? Can you all remember I gave you all a homework in paper number 1 hurry 2 hurry to draw all the Lewis structures? Can remember? Onnalamai, take a separate paper now. Take a separate paper. Take a separate paper. Try to draw this Lewis structure by your own. Try to draw these Lewis structures by your own. These 4 Lewis structures first draw their Lewis structures. Hydrogen, chlorine, oxygen, nitrogen. Okay. Done. Done. Right. Those who are struggling, put a trick. Look, hydrogen you have to separately memorize and keep. H single bond is there. Then this is nothing, no, H single bond is there. Just memorize this and keep. H single bond. Right. Chlorine. You all tell me chlorine belongs to which group? Group number? Group number 7. Chlorine belongs to group number 7. Oxygen belongs to group number 6. Good. Nitrogen belongs to group number 5. Perfect. Group number 5. 2 chlorine. Chlorine Cl2 ke anne lamai 2 chlorine are there. How many bonds are there between the chlorine? Lamai chlorine group 7. You subtract 8. 8 minus 7. How much you get? 1. Then how many bonds chlorine likes to form? 1 bond. Group number 7. 8 minus 1. 8 minus 7 is 1. How many bonds chlorine like to bond? 1 to make 1 bond. So chlorine, remember, always tries to make one bond. Not only chlorine, any group 7 element is like that. Group 7 element, 8 minus 7, 1, they like to make one bond. One bond gone, how many free electron will be there? 6 free electrons. Draw them as pair. Draw them as pair. So basically, chlorine is group 7, makes one bond, 6 free electron. One bond, 6 free electron. Now coming to oxygen. Let me oxygen group 6, 8 minus 6, how much? 8 minus 6, how much? 8 minus 6, 2. Then oxygen likes to make how many bonds? 2 bonds. 2 oxygen are there, double bond is there. Oxygen likes to make 2 bonds and there will be 4 electron remaining. 4 electron remaining. It makes, there you go. It makes 2 bonds, 4 electron remaining. 2 bonds, 4 electron remaining. Nitrogen, group 5, 8 minus 5. What's the number? What's the number? 3. It likes to make how many bonds? 3 bonds. Nitrogen, 3 bonds are there. Triple bond is there. Triple bond is there. 2 electrons remaining. 2 electrons remaining. If I separately write, there you go. 3 bonds, 2 electrons remaining. Look at these numbers. 1 bond, 6 electron. 2 bond, 4 electron. 3 bond, 2 electron. 1 bond, 2 bond, 3 bond. 6 electron, 4 electron, 2 electron. Group 7 makes 1 bond, 6 electron remaining. Group 6 makes 2 bonds, bond will increase. Then electron will decrease. 4 electron remaining. Group 5, 3 bonds, bond is increasing. Number of electron decrease, 2 electron. Group 7, 1 bond, 6 electron. Group 6, 2 bond, 4 electron. Group 5, 3 bond, 2 electron. Basically, chlorine forms 1 bond, 6 electron remaining. When bond is 1, 6 electron will be remaining. Hydrogen you learn separately. When bond is 1, 6 electron. When bond is 2, 4 electron. When bond is 3, 2 electron. See, 1 bond, 2 bond, 3 bond. 1, 2, 3. 6 electron, 4 electron, 2 electron. 6, 4, 2. That's the logic. That's the logic. Hydrogen separately you need to learn. Hydrogen always like to make 1 bond, no free electron. So basically, hydrogen makes 1 bond, no free electron. Chlorine, group 7. 8 minus 7, 1. 1 bond is very less, no? Electrons will be high. 1 bond, 6 electron remaining. Oxygen, group 8 minus 6, 2. 2 bonds. Bonds have increased. Then electron will decrease. 2 bonds, 4 electrons remaining. Nitrogen, group 5. 8 minus 5, 3. 3 bonds. Bonds are increasing. Electrons will furthermore decrease. 2. 2 electrons remaining. H right. Now we'll go to little complicated structures. With this logic, we are going to do water, carbon dioxide. Water, ammonia, carbon dioxide, methane. Now see how I draw these structures. First, you need to know how many atoms are there. Hydrogen 2, oxygen 1. 2 hydrogen, 1 oxygen. 2 hydrogen, 1 oxygen, center. The person who is singly present will be at the center. Correct? No, now can you put 2 hydrogen at the center? Impossible. Oxygen at the center. 2 either side. You consider 1 atom and draw the structure, will you? See, I will consider oxygen, central atom. We know the logic about oxygen. No? Oxygen always tries to make 2 bonds. It can make 2 bonds. How many electron remaining? 4 electron remaining. Oxygen likes to make 2 bonds, 4 electron remaining. It likes to make 2 bonds. Now, can I draw both the bonds like this? If I draw it, how to make the bond on the hydrogen? Can I put it on hydrogen? Then equally, I should distribute the bond. One bond goes to hydrogen, the other bond goes to the other hydrogen. Correct? One bond, one bond. 2 bonds gone. How many electron remaining? Oxygen, how many electron always remains? 4 electron remain. 4 electron. Now, automatically, hydrogen should get satisfied. Hydrogen likes to make how many bond? One bond, correct? Is there any free electron remaining? No. It's right. That's the structure of water. So logic is oxygen makes 2 bond, 4 electron remaining. See, 2 bond, 4 electron remaining. Hydrogen make 1 bond, no electron remaining. Ammonia. Nitrogen, 3 hydrogen. Who should be at the center? Guaranteed nitrogen at the center. 3 hydrogen na there. 3 hydrogen na there. You all tell me, nitrogen likes how many bonds? Nitrogen likes to form how many bonds? 3 bonds. How many electron remaining? How many electron remaining? 2 electron remaining. Nitrogen likes to make 3 bonds. Now, can I put all the 3 bonds like this? Oh, I need to equally distribute it. 1 bond there, second bond there, third bond there. 3 bonds gone. How many electron remaining? 2 electron remaining. You draw it on top. Automatically, hydrogen get fulfilled. See, hydrogen 1 bond, no free electron. Hydrogen 1 bond, no free. Ammonia. Carbon dioxide. Remember, carbon likes to form 4 bonds. Carbon likes to form 4 bonds. No electron remaining. Correct? No? Look at carbon. Carbon is 4th group element. Likes to make 4 bonds. No 4 bonds. No free electrons. 0 free electrons. Look at the order. Will you? Group 7. 1 bond. 6 free electrons. Group 6. 2 bond. 4 free electrons. Group 5. 3 bond. 2 free electron. It's got a group 4. 4 bond. No free electron. See, 1 bond, 2 bond, 3 bond, it's got a 4 bond. 6 free electron, 4 free electron, 2 free electron, no free electron. 7th group, 6th group, 5th group, 4th group. So carbon likes to make 4 bonds, no free electron. Always keep that in mind. Carbon likes to make 4 bonds, no free electron. So if I draw the structure, carbon to oxygen, carbon should be at the center, both the oxygen on either side. Carbon likes to make 4 bonds. Now, can I put all the 4 bonds like this? No. I should equally distribute it. How to equally distribute it? This side I'll put a double bond. The other side I'll put a double bond. Is there any free electron around carbon? No. 4 bonds gone, no free electron. But look at oxygen. Oxygen likes to make 2 bonds. Is there any free electron remaining? Is there any free electron remaining on oxygen? Yes. How many free electron? Oxygen, how many free electron? 4 free electron. 1, 2. Next, methane. 1 carbon, 4 hydrogen. Carbon likes to make 4 bond. 4 hydrogen na there. Equally distributed. 1, 2, 3, 4. Is there any free electron around carbon? Any free electron around hydrogen? And hydrogen makes 1 bond, that is also satisfied. So the basic logic is hydrogen you learn separately. Hydrogen 1 bond, no free electron. Next, go in order. Group 7, group 6, group 5, group 4. 1 bond, 2 bond, 3 bond, 4 bond. 6 free electron, 4 free electron, 2 free electron, 0 electron. That's the logic. With that, you can draw any structure. Understood? Okay. Shall I note it? Yes, of course. I already gave it as a homework for those who came previously. Draw the structures. Now no need to memorize it. Now we all know the logic. Logically, you can draw the structure. Group 3, 2, 1. You're telling me group 3, 2, 1. First of all, do they form covalent bonds? Have you ever seen sodium forming covalent bond? Calcium forming covalent bonds? They form ionic bonds. You can't draw Lewis structures for them. Yes, aluminium can form. Aluminium chloride, you can draw Lewis structure. If so, aluminium will have 3 bonds. Okay, no? So put it to the mind. Put it to the mind. Hydrogen 1 bond, no free electron separately. Chlorine 1 bond, 6 free electron. Oxygen 2 bond, 4 free electron. Nitrogen 3 bond, 2 free electron. Carbon 4 bond, 0 free electron. Okay. Now what are they asking? Which of the following is the molecule with highest number of covalent bond? Dingala will draw the structure. Oxygen, nitrogen, ammonia, carbon dioxide. Oxygen, nitrogen, ammonia, carbon dioxide. Oxygen, nitrogen, ammonia, carbon dioxide. We'll draw the structures. Oxygen. Oxygen form double bond. 4 free electron. Nitrogen. Nitrogen form 3 bonds. 2 free electron. Ammonia. Nitrogen forms 3 bonds. 2 free electron. Carbon dioxide. Carbon forms 4 bonds. Double here, double there. 4 free electron. Count the number of bonds. Here 2 bonds. Here 3 bonds. Here 3 bonds. 2 plus 2, 4 bonds. Where highest number of bonds? Where highest number of bonds? Guaranteed where? Carbon dioxide. Actually, you don't need to draw the structure. You all already know the logic, no? Group 6, 2 bonds. Nitrogen is there. Nitrogen group 5, 3 bonds. Nitrogen is there. Group 5, 3 bonds. Carbon dioxide. Carbon, group 4, 4 bonds. Now, with that our previous logic, you can answer this question one shot without even drawing the diagram. Oxygen group 6, 2 bond. Nitrogen group 5, 3 bond. Again, nitrogen group 5, 3 bonds. Carbon dioxide, carbon group 4, 4 bonds. And guaranteed it's carbon dioxide. No need to draw. Within 1 minute, you can answer. No, not even 1 minute. Within 10 seconds, you can answer the question. Next. Heat is transmitted from sun to earth by, that is by radiation. Heat from sun to earth comes from radiation. Next question. As was extracted by a student from an environmental pyramid, that ecosystem has one producer, 8 primary consumer, 23 secondary consumer. One produce. That is question number 7. One produce 8 primary consume. Eight primary consumer. 23 secondary consumer. 23 secondary consumer. The students have extracted this information from what kind of pyramid, right? Always remember when you are drawing a pyramid, number pyramid, biomass pyramid, energy pyramid, producer comes on bottom. Base is made from the producer. One producer is there. So base block is very small. Only one producer is there. 8 primary consumer. Second block is 8. 8 is bigger than 1. 8 primary consumer. 23 secondary consumer. 23 is even greater than 8. They have given the number of organism, so it is guaranteed a number pyramid. What kind of number pyramid? If you look at this pyramid, what kind of number pyramid? Upright or inverted? Upright or inverted? Pyramid is inverted. Inverted number. Inverted number. Okay. So it's an inverted number pyramid. Inverted number pyramid is answer number 2. Answer number 2. How can we find if it is a biomass pyramid? Then they will tell the mass of it, the biomass of it. In an environment, the biomass of the pyramid, biomass of the producers are this amount, this much of kg. Primary consumer, this much of kg. Now here directly the number of organisms are given. So it's number of organisms. Number. Eight question already done. 9 and 10. Question 9 and 10 are based on the following information and the illustration. Production of hemoglobin is disturbed by thalassemia, an inherited disease caused by the gene mutation in a somatic chromosome. With regard to the production of hemoglobin naturally, the dominant gene is capital T, while the mutant recessive gene is simple t. A, B, C, D are indicated in the F1 generation. A thalassemic patient belong to F1 generation is. First we will write the combinations there. First we will write the combinations there. Look at A. Capital T, capital T. Dominant is joining. Capital T, capital T. Remember, thalassemia patient is due to double recessive factor. If you have simple T factor, that is thalassemia patient. Double recessive will only show the disease. Then you all tell me, capital T, will it show the disease? Fellow is healthy. Doesn't have anything about the disease. Recessive is only diseased. Recessive is diseased. Here there is nothing about the recessive. Nothing about recessive means this person is healthy. This person is healthy. So I have one healthy person. One healthy person. Look at B. Capital T, simple t. Capital T, simple t. Dominant capital T, recessive simple t. What will come out? What will be phenotypically expressed out? Your dominant gene. Dominant gene is capital T. Capital T will be phenotypically expressed out. You all tell me, is capital T disease condition? Is this person having anything, is he going to show the disease? No, he doesn't show the disease. But has the gene for the disease. That means maybe can transfer the disease to the next generation. You call them what? Carriers. So this is a carrier. B is a carrier. Look at C. Look at C. Look at C. C combination. Simple T is there, capital T is there, always capital letter is written first, always dominant is written first. Capital T, simple T. Again, same like B. Dominant is capital T, recessive is simple T. What kind of a person? Healthy or carrier or disease? Guaranteed a carrier. Has the disease causing gene but doesn't show the disease, can give the disease to the next generation. So two carriers are there. Two carriers are there. If I made the question, I will not give this diagram. O-level question, they are given the diagram and asked. Last one. Simple T is there, simple T is there. D, gene combination is simple T, simple T. What can you tell about the person? If simple T is there, guaranteed the person is deceased. So D person is deceased. So one deceased individual is there. One deceased individual is there. One deceased individual. So what are they asking? A thalassaemic patient belong to F1 generation is. Who is thalassaemic patient here? D. D is a thalassaemic patient. Answer 4. The ratio among thalassaemic patient, healthy disease carriers, healthy individual belong to F1 generation. Thalassaemic patient. How many patients we have? 1 is 2. Healthy disease carriers. How many carriers we have? 2. 2 carriers are there. Is 2. Healthy individual. How many healthy individuals we have? 1. 1 is to 2 is to 1. Answer is answer. Clear? Clear with all those sections? Only thalassemia recessive gene disease? No. All the diseases we discuss in inheritance are recessive gene disease. Hemophilia due to double recessive factor. What you call color blindness, double recessive factor. All are recessive factor. Okay. Okay then. With that, we are done for today. With that, we are done for today. And with that, we have finished now 130 MCQs. 130 MCQs with reviews we are done. By tomorrow, no, tomorrow. Tomorrow no session. Tomorrow no session. Wednesdays we don't have session. Again, I'll be meeting you all on Thursday. By Thursday, we will be touching our 130th, maybe 40th, 140th mark. Okay. Okay, then keep working hard. Keep working hard, right? I'll meet you all again, not tomorrow, the day after tomorrow. Okay.